Our solar system was born about 5 billion years ago. Humanity has been around for millions of years. Civilization, some 10,000. We have been researching our history for at least 20 centuries, digging out the origins of mankind for only one or two. And it is less than 20 years since we first escaped from this planet to perform direct experiments on the nature and history of the solar system. A complex package of experiments called Voyager is designed to take the first thorough close-up look at the giant outer planets. 2 missions are launched in August and September 1977 aboard 2 Titan Centaur rocket vehicles. Voyager 1 will reach Jupiter in March 1979. Voyager 2 4 months later. Each is swung around Jupiter and accelerated onward by its gravity. Arriving at Saturn in November 1980 and August 1981. The first will be lofted upwards out of the solar system. If all goes well, the second could be propelled by another gravity turn on out to Uranus, the 7th planet, arriving in January 1986. The mission is controlled at the Caltech Jet Propulsion Laboratory, which is responsible for unmanned planetary exploration for the National Aeronautics and Space Administration. This is where the Voyager spacecraft were designed and assembled. Each Voyager has a mass of 800 kilograms, almost a ton, as it coasts between planets. Its orientation in space is stabilized, and its many electronic subsystems are controlled by onboard computers. Progress is monitored on Earth through a steady stream of scientific and engineering information, transmitted through the large dish antenna, which is more than 3.5 meters or 12 feet across. 400 watts of power are supplied by 3 radioisotope thermoelectric generators running on long-lasting nuclear fuel. 16 tiny rocket thrusters, fueled by decomposing hydrazine, turn the craft or change its velocity when required. The 11 scientific experiments are carried out through instruments all over the spacecraft. Those which must turn and look at a planet or satellite are clustered on a precisely controlled scan platform. The wide-angle and high-resolution television cameras, ultraviolet and infrared spectrometers, and a photopolarimeter. The particle instruments, including plasma, cosmic ray, and low-energy charged particles, are grouped nearby. Radio science uses the spacecraft communications equipment, while radio astronomy and the plasma wave detector have independent receivers and shared antennas. The magnetometers are mounted out along a 40-foot boom. The first major subject of these 11 experiments is the giant planetary system called Jupiter, its magnetism, plasma envelope, and radiation balance. The large Galilean satellites, 2 of them bigger than the planet Mercury, and the gargantuan weather of Jupiter's deep and colorful atmosphere. As Io emerges from Jupiter's shadow, its reflective surface warms to a reddish hue. Re-entering the world of computer graphics, we move north of the Jovian system to view the Voyager flybys. After more than 2 months of observing Jupiter from afar, Voyager 1 approaches from the sunward side, all sensors open. Curved around by gravity at 300,000 kilometers above the cloud tops, it does a close survey of Io, passing through its flux tube. then resumes probing Jupiter's night side and twilight zone and encounters Ganymede. Finally, it flies by and surveys Callisto. This near-encounter period has lasted more than 2 days. Four months later, Voyager 2 arrives from a slightly different angle. First, it examines Callisto at medium range. Then a close-range survey of Ganymede, viewing new territory not seen on the previous encounter. A medium-distance observation of Europa, which Voyager 1 passed at a greater range. Then passed Jupiter at a range of over 600,000 kilometers. Now, as seen from Earth, Voyager 2 passes behind the planet, as the first one did, permitting a deep probe of the atmosphere by the dual-frequency radio beam from spacecraft to Earth. This Voyager mission greatly improves resolution of Jupiter. Let's start with one of the best photographs taken from Earth. Now the great red spot and a picture from the Pioneer 10 spacecraft. Note the white oval below the red spot. This Apollo photograph of a storm on Earth simulates the sharper detail which Voyager's television can see. The improvement is even greater for the satellites, for the spacecraft will pass very close to some of them. Here's Ganymede from the Earth. This Pioneer picture improved Ganymede resolution significantly, but Voyager will see more than 100 times better, as seen in this final simulation, actually a picture of Mars. Overall, Voyager will achieve resolutions nearly 1,000 times finer than can be seen from Earth. Now, in March 1979, let's board Voyager 1 for a ride through the Jupiter system. We're living more than an hour every second, and the field of view is 40 degrees for comfortable vision. We fly towards the planet over the night-day terminator until we see the dark side. Past Jupiter, we pan up to Io, field of view now 12 degrees. Under the South Pole at a closest range of 22,000 kilometers. Looking back at Jupiter, we see the Earth and the Sun emerge from occultation. We were in eclipse for 2 hours. Now, in a narrow-angle field of view, we fly by Ganymede. And then, over the North Pole of Callisto. As Voyager plunges outward into the night, we look back at Jupiter and see the night side and crescent shrinking behind us. At Jupiter encounter, the Voyagers are so far from Earth that their signals take at least 40 minutes to reach us. They are picked up by the giant antennas of the Deep Space Network, located around the world, and read in the Mission Control and Computing Center in Pasadena. Here, radio commands are generated for transmission to the two craft. When Voyager 1 begins its approach to Saturn, the commands will take almost an hour and a half to reach it. The planet Saturn may hold more scientific puzzles than Jupiter. Its rings, its low density, and its varied satellites make it a very different and fascinating object for exploration and study. Voyager 1 is targeted for close examination of Saturn, its largest moon Titan, and its unique rings. Both Voyagers will cross the ring plane outside of the hazardous rings. We move to a vantage point north of the Saturnian system. About 18 hours before reaching Saturn, Voyager 1 flies by Titan at very close range. Continuing its approach from the sunlit side, Voyager scans the Saturn system with improving resolution, observing the rings, and encountering Mimas, Dione, and Rhea, small inner satellites, then leaving Saturn with sufficient speed to escape from the solar system. About 9 months later, Voyager 2 surveys the Saturn system. Choice of the Uranus option aiming point permits a mid-range Titan encounter. Continuing to close upon Saturn and a cluster of satellites, Voyager surveys Tethys, Enceladus, and Mimas, with a low inclination pass of Saturn dictated by the gravity assist corridor for continuing to Uranus. Alternatively, the second mission could be commanded to more nearly duplicate the first with a close Titan encounter and occultations of Saturn and her rings. Now we return to Voyager 1 for a ride-along tour approaching Saturn and Titan. At a 30-degree field of view, we view Titan's day, twilight, and night regions, and see the Sun and Earth emerge from occultation. Precise navigation brought us within 4,000 kilometers of Titan's surface. At a 60-degree field of view, elapsing 43 minutes each second, we continue approaching Saturn, viewing the sunlit side. Passing south of the ring plane, we cross from morning to dawn to night, and then see Earth and Sun occulted by the planet and then by the rings. One of the last satellites to be surveyed is Rhea, viewed from the north at a 3-degree field and a range of 60,000 kilometers. Finally, we look back at Saturn, dwindling into night. If all goes well during the first Saturn pass, Voyager 2 could be targeted to continue to Uranus, the 7th planet, taking more than 4 years after the Saturn flyby. The computer lets us board Voyager for a final ride. Uranus spins about an axis so tilted that when Voyager arrives, the North Pole is pointed toward the Sun. The spacecraft drops through the system from the sunlit northern to the dark southern hemisphere, going past the planet close to a small satellite, such as Miranda or Ariel, or perhaps even attempting a final gravity assist passage on to the remote Neptune. Earth and Sun occultations of Uranus would occur for atmospheric measurements. And then Voyager would move on out, like its twin, somewhere north of the ecliptic plane, looking back at a sun which is only a star, and an Earth which has vanished among the stars.